All right, so this video is just to recap the information that we did in class. What I suggest is that you pause this video and try to do all of this work yourself. If you can do it yourself, you don't really need to watch this video. This video is just kind of a recap if some of the information you missed from class, or if you had questions about a certain part, hopefully this video can help you there. So in class, we talked about how transformations take place on an equation. So there's some key parts of our equation that we want to pay attention to. So the sign in the front would tell us if it's positive, there was no transformation. If it's a negative sign, that means our graph reflected across the x-axis. This pen does not work, so let me try to find a different one. Reflected across the x-axis. Then, if there's a value in front of your parentheses, or in front of your absolute value sign, or in front of your square root, this is going to be a stretch, a vertical stretch by that factor. So if it's a 2, it's a vertical stretch by 2. If it's a 3, it's a vertical stretch by 3. But it's a vertical stretch by that number. Then these two values here make up your shifts right and left. So this H value tells us if we shifted right or left. If it's a positive value in here, that means we shifted to the left. If it's a negative value, that means we shifted to the right. Then our K value tells us if it's positive K, we went up, and if it's negative K, we went down. So H and K actually make up our new vertex of our function. And so the H value shifts left or right, and the K value shifts up or down. So if we think about this first example, so the equation of the parent function, so because of this 3, this is a cube, this is a cubic because of the 3. So that parent function is y equals x cubed, right? This is a cubic. So then looking at the equation, this transformed function, we want to figure out what transformations took place. So there's no negative in front, there's no value in front, so there was none of the reflection or the vertical stretch. This minus 2 means I went to the right 2. And then this plus 5 means I went up 5. So those are the two transformations that took place on our original parent function. All right, so if we look at number 2, we have this negative sign in the front. So that tells us that we reflected across the x-axis. Then there's no numbers, there was no vertical stretch. Then I have a plus 1 inside with the x. Right, it's inside my square root. So that plus 1 means I went left 1. I wrote this in the wrong place. I'm so sorry. But I'm just going to write my left 1 here. And then my minus 7 means I went down 7. What I was originally supposed to write was the equation of my parent function, which is y equals the square root of x. Right? This is my square root function. So then from my parent function, the negative meant I reflected across the x-axis. The positive 1 inside the square root, inside with the function, like we had the inside with the parentheses here is our right or left. So because it was positive, I went left 1, and then this minus 7 on the outside, and I went down 7. So those are my 3 transformations that took place. Okay, so then the next thing we had to do was looking at a graph determined, right? This is looking at an equation determining our transformations. Now we're going to look at our graph to determine transformations. So by looking at this graph, we should know that this is a quadratic. Now our equation to our quadratic is y equals x squared. So then if we think about what a quadratic looks like, normally it looks like this going through 0, 0. We want to figure out all the transformations that took place. So first of all, it's reflected over the x-axis. So that's one of our transformations. Or it flipped over the x-axis. Then that normal vertex that's at 0, 0 is now up here. So I need to figure out where it moved from 0, 0. So it went left 1, 2, 3, 4. So it went left 4, and then it went up 1, 2. So now, with these transformations, we can take our parent function and add in these transformations to make up the equation of our transform function. So we know that because it reflected over the x-axis, it starts with a negative value. Sorry, the lights in my room just turned off. Hang on one sec while I get them to turn back on. There we go. All right, we're back in business. So because it reflected over the x-axis, that means our equation starts with a negative sign. Then in parentheses, I have x and whatever my right and left transformation was. So because I went left 4, we're going to use a positive 4 value. You have to think kind of the opposite of what your brain would normally go to, right? We went to negative 4, but we have to change the sign. So this is going to be a plus 4 to represent left 4. And then we put our squared on the outside of our equation, and then up 2 means we would add 2, right? Anytime we go up, we're going to add. So we would add 2 to our equation. So this is the equation of our transform function. The negative is our reflection. Positive 4 means left 4. Up 2 means positive 2. All right, let's look at our next example. So number 4 is a cubic. We should know from our pictures, we've practiced with our parent function flashcards, what the picture and the name and the equation look like. So normally a cubic looks like this going through 0, 0. So our equation is y equals x cubed. So now if we look at our transformations, normally this point of inflection right here, where it kind of changes direction, goes through 0, 0. So our graph from 0, 0 went right 2, so I'll write that down, right 2, and then it went up 1, 2, 3, 4. So it went up 4. So those are the transformations that took place on my graph. So when I write the equation, I have y equals, it did not reflect or stretch, so I'm not going to put anything in front. And then I'm going to symbolize right 2. So if we go back to this equation up here, anytime we go right, we're using a minus sign. So this is going to be minus 2. And then because we went up 4, that means from our original function, we're going to add 4. So this minus 2 symbolizes our right 2, and this plus 4 symbolizes our up 4. Yeah, if you look at this original equation, it has a minus in it. So we're just putting this 2 value in there, and it's keeping it negative. And then in this example, when we went to negative 4, when we placed negative 4 here, negative times negative became positive 4. So that's really why our signs are the opposite of what we would think they're going to be. But we just have to remember the inside of the parentheses has the opposite sign. So that's how we write our transformations and the equations from our pictures. So hopefully that was a little extra practice. So then the last part of transformations that we went over in class was moving any type of function from one graph to another. So for instance, this is f of x. This is what we're considering the parent function. So this graph could really look like anything. So then from this graph, I want to do this transformation. Well, a plus 1 on the inside means I'm going left 1. So the transformation is I'm going to take this graph and I'm going to move it to the left 1. So every point, and I'm just going to focus on these 3 main points here, I'm moving to the left 1. So for instance, this was originally at 1, 2. This point here is originally at 1, 2, and I'm just going to move it to the left 1. So I'll be here at 0, 2 instead. And then this point was at 3, 4. So I go to 3, 4, and then I move left 1. And then my last point was at 4, 3. So again, I go to 4, 3, and then because of this transformation, I move to the left 1. So all I did was take the original function that they gave me, which we're just calling f of x. This picture could be anything. And we're doing the transformation that is in this equation here, or in this problem here. So plus 1 meant I moved left 1. So I took this exact graph and I just moved it to the left 1. So hopefully this helps you as you continue working with transformation. Just recap video. Obviously, if you have any further questions, feel free to email me or ask me at our Monday remote meetings.